All right, let's get right into it. Today, we're tackling something that's absolutely essential for any modern developer, building a bridge between your Node.js app and a MySQL database. And by the end of this, we're not just going to talk about it, we're going to build a fully functional REST API from scratch. But first, have you ever really thought about it? You've got your application over here on the mainland, right? That's where all the action is, where your users are clicking around. And then way over there on its own little island is your data, all tucked away in a MySQL database. They can't just yell at each other across the water. So how do they actually communicate? Well, you guessed it. They need a bridge. And that's exactly what a REST API is. It's that perfectly engineered causeway that lets information travel safely and super efficiently from the app to the database and back again. And today, that's what we're doing. We're building one, brick by brick. Okay, first things first. Every great structure, whether it's a suspension bridge or a piece of code, needs a rock-solid foundation. So before we write a single line of API logic, we've got to get our workspace prepped and ready to go. So our prep work is just 3 quick steps. First, we'll grab our tools. That's Express for the server itself, MySQL2, which is the driver that lets Node speak MySQL's language, and .n, a super important little package for keeping our secrets, well, secret. Then we'll actually create the database and table, and finally get our environment variables all set up. So this is our island of data. It's the employees table we're making in MySQL. Now zoom in on that email column for a sec. See how it has a unique constraint? That's a rule we're telling the database to enforce. No 2 employees can have the same email. And that's a little detail our API is going to have to be smart about later on. Okay, this right here, this is a huge security best practice. We're creating a special file, it's called .env, just to hold these sensitive database credentials. This file lives completely separate from our main code, and you never commit this thing to Git. Ever. It's kind of like keeping the keys to the castle in a totally separate, secure lockbox. All right, our foundation is officially set. The ground is prepped. So now it's time for the main event, building the structure itself, the API server using Node.js and Express. So you'll hear this term a lot, API endpoint. What is it? Well, if the API is our bridge, think of an endpoint as a specific lane of traffic or a designated doorway. Each one has its own unique URL, like /API/employees, and it's built to handle one very specific job, like getting all the employees or adding a brand new one. We're going to start with the absolute classic, the most fundamental endpoint you can build. It's a GET route. And its only job is to go to the database, grab a list of all the records in our employees table, and bring them back. Simple as that. And believe it or not, inside our Express route, it's just these 2 lines doing all the heavy lifting. That pool.query line sends a simple SQL command over to the database, and once we get the data back, res.json neatly packages it all up as JSON and sends it right back as the response. That's it. Now, reading data is cool, but an app that only reads data isn't that useful, right? We need to be able to write data too. So next up, we're building the post route, which is what's going to let us create a brand new employee record in our database. Okay, this piece of code is critically important. To stop a really nasty attack called SQL injection, we never, ever put our variables directly into the query string. Instead, see those question marks? They are your best friends. They're just placeholders. The database driver then safely combines the query and our data, which we pass along in a separate array. You know, this is what separates a good API from a great one, how it handles things when they go right and when they go wrong. When it works, we send back a 201 created status code. But remember that unique email role? If we try to add a duplicate, our code is smart enough to see that specific database error and respond with a 409 conflict. That gives the person using the API clear, useful feedback. The bridge is built, the foundation is solid, the structure is up. Now for the really exciting part, the moment of truth. Let's send the first bit of traffic across and actually test our API to see it in action. So, there are a couple of great ways we can test this thing out. We could use a command line tool like curl for really quick, raw checks right from the terminal, or we could use fetch inside a web browser's JavaScript to hook it up to an actual user interface. For our first test drive, we're going to use curl. It's just the perfect tool for the job because we can fake a post request directly, and we don't have to go build a whole front-end app just to see if our backend works. So, what are we looking at here? Well, -x post just tells curl we're making a post request. Then we give it the full URL to our endpoint. The -h part sets the content type header, which is our way of telling the server, hey, I'm sending you some JSON. And finally, -d has the actual JSON data for our new employee, John Doe. And boom, we hit enter on that curl command and we get something back from our server. This JSON you see here is the proof. Our server got the request, it processed it, and it sent back a reply. It actually worked. And what this response tells us is that the whole round trip was a success. Our request went across the bridge, the server understood it, the database inserted the new record, and even assigned it a new ID of 4. And then the server sent this confirmation right back to us. Perfect. Okay, so it works. That's awesome. But a bridge that just works isn't enough, right? A professional grade bridge needs to be safe. It needs to be reliable. So let's do a quick safety inspection and run through some pro tips for making sure your APIs are truly production ready. These are the absolute non-negotiables. First, always use prepared statements to kill SQL injection dead in its tracks. Second, always hide your credentials in .env files. Third, use a connection pool. This is a big one for performance. Instead of making a new database connection for every single request, a pool keeps a bunch of them ready to go, which is way faster. And finally, always use meaningful status codes. And when you're ready to level up, you can start validating all the data that comes into your API to make sure it's clean. If you have an action that needs to do multiple things in the database, you'll want to use transactions to make sure everything succeeds or nothing does. And as your app gets bigger, you might look into an ORM like SQLize to manage your data for you. So there you have it. That's the blueprint. You've now seen how to build that secure, reliable data bridge between your application and your database. The foundation is solid, the structure is sound. The only question left is, now that your bridge is built, what are you going to connect to it?